Hello and welcome to Algebra 1, Chapter 6.6, and today we're going to talk about solving inequalities involving absolute values. So 6.5 was solving equations with absolute values. This is an extension into inequalities. So the first set that we're going to consider is if you're talking about the inequality less than. So if we have the absolute value of something is less than a number. And so, for instance, if we have the absolute value of x is less than 5, so which x's would work here? Obviously 5 would work. The absolute value of 4 would work. 3. On down to what would be the smallest number you could put in there that would work? Well, you could put in -4, right? Because the absolute value of -4 would be +4, and +4 is less than 5. And here I'm only talking about integers, but you could really then put in -4.99, and that would still be less than 5. So if we're talking about it's between these numbers, so obviously here 5 didn't work, but 4 did, we're going to be between these numbers, then this is going to be an and. And so we're going to learn that every time you have a less than with an absolute value, it's going to turn out to be an and. And so these two cases that you're going to consider, the first one is what if what's inside the absolute value is positive, which is actually the exact same thing you did for equations. And the other one is if what is inside the absolute value is negative. So those are our two cases, and we're going to find the intersection of them, which means we are looking for that and inequality. Okay, so here we're going to look at the absolute value of s minus 3 less than or equal to 12. So we just talked about the case 1 is what if what's inside the absolute value, what if it's less than the positive. So the only difference here, remember when you had an equation and it was equal to 12, and you wrote s minus 3 equals 12, and you wrote s minus 3 equals -12. So here's the only difference is I had my positive case, that was my first case there. Your negative case, you're going to flip the inequality, because to make that 12 be a -12, we're going to consider that we multiplied it by -1, and so you have to flip your inequality. So here's our two inequalities. You're going to solve them both. S is less than or equal to 15, and then solve the other one. S is greater than or equal to -9, and if I take a second here to graph it, I'm going to count by threes. Still run out of room. All right. So less than or equal to 15 looks like this. Greater than or equal to -9 looks like this, and there's that and. So remember, ands you have to write as 1. Low number on the left, high number on the right. Inequalities opening to the right. So there's your answer then. Okay, so let's do that again. You're going to write your positive case. So n minus 8 less than or equal to 2. And then for your negative case, flip the inequality and then make it a -2. Okay, so we're going to add 8. Get n is less than or equal to 10. Add 8. N is greater than or equal to 6. Okay, and you should be able to write it then with the 6, because n is greater than or equal to 6, less than or equal to 10. So there's your answer, and then you are going to graph them. 5, 6, 7, 8, 9, 10, 11. And we are less than or equal to 10, which looks like that, greater than or equal to 6, which looks like that, and there's my graph of an and. Okay, so if you start out with a less than, you're going to end with an and for an answer. So what happens if you start out with a greater than? Okay, so the absolute value of x is greater than 5. So 6 would work, 7 would work, 8 would work, right? All of those would have absolute values that are greater than 5. But then also, -6 would work, -7 would work. These are going to have absolute values that are greater than 5. So if we're looking at all those numbers and all those numbers, this is now an OR. Okay, so same two cases. You're going to do a positive case and a negative case, and you are still going to flip your inequality on your negative case. And this time, though, we're going to have a union of our answers because it's those arrows that are going away from each other. All right, so you always start the same way. You're going to write your two cases. And remember, your cases do not have the absolute values in them. So greater than 9, there's my positive case. And then 3y minus 3 is less than -9. That's the important part right there. Flip that inequality on your negative case. All right, so solving these, we get 3y is greater than 12. Divide by 3y is greater than 4. Solve the other one. 3y is less than -6. Divide by 3, y is less than -2. And if we graph it, before I write my final answer there, -3, -2. Okay, if we look at this, greater than 4 looks like that. Less than -2 looks like that. It's an OR, so we put the word OR in the middle, and you got your answer. All right, so once again, greater than, it's going to be an OR. We're going to write our two cases. 2k plus 1 is greater than 7. 2k plus 1 is less than -7. So we're going to solve both of these. So 2k is greater than 6. K is greater than 3. 2k is less than -8. K is less than -4. And it was an OR, so we're going to go ahead and put the word OR in the middle of it. And then when we graph it, we have -5 to 4. So greater than 3, make sure you get the right type of circle there, less than -4. There we go. All right, so here's a concept summary for you. So 6-5 was equations, and you just wrote your two cases. What's inside the absolute value is equal to n, or it's equal to -n. And then we just got done talking about if you have a less than case, here's less than, that it's going to end up being an and statement. And if you have a greater than case, you're end up going to be an or statement. And we'll talk a little more in class about how to remember that, because it is something extra to remember. But right now we just need to make sure to have it written down. Okay, and here's our last example for the day. The average annual rainfall in California for the last 100 years is 23 inches. However, the annual rainfall can differ by 10 inches from the 100-year average. So what's the range of annual rainfall in California? So range would mean we need a low value and we need a high value. So what's the low end that the amount of rainfall could be? It could be 13 inches all the way up to 33 inches, right? So you just take your average, or what it should be, and then we added and subtracted 110 from that, right? The 100 really didn't have anything to do with it. So we added and subtracted 10 to find that range. All right, there's your 6-6 notes. We will finish the few examples we didn't do in class. Let me know if you have any questions. See you later.